Fermat's last theorem. The tools of Pierre de Fermat. My motto: plain honesty, simple truth, easy understanding. The joy of finding things out for yourself. We are fooled to believe by modern-day mathematicians that the tools required by Pierre de Fermat to prove his last theorem were not available to him in his era, and that what he had was a eureka moment. This video will, I hope, dispel that misconception. If not, then I hope you will be a little more enlightened. Take the Fermat equation, z to the n equals y to the n plus x to the n, and write it in its two other variants. Z to the n minus y to the n equals x to the n, and z to the n minus x to the n equals y to the n. Divide the sum or difference of the two terms by their equality to make all three variants equal to each other and to 1. Equating the three expressions, we get 1. Y to the n plus x to the n divided by z to the n equals 2. Z to the n minus y to the n divided by x to the n equals 3. Z to the n minus x to the n divided by y to the n, and all equal to 1. Pair the equations and simplify. We will then end up with three quadruples. The first one being z to the 2n equals z to the n y to the n plus y to the n x to the n plus x to the 2n. And the second quadruple, z to the 2n equals z to the n x to the n plus y to the n x to the n plus y to the 2n. And the third quadruple, z to the n y to the n equals y to the 2n plus y to the n x to the n minus x to the 2n. What we have produced are three quadruples of power equal to n. These are the Fermat-Bateman Quadruples. Take a Fermat-Bateman quadruple, in this case z to the 2n equals z to the n y to the n plus y to the n x to the n plus x to the 2n. Restate with the two square terms as squares, and then replace z to the n with y to the n plus x to the n. Then let y to the n equal a and x to the n equal b, and then we will end up with the identity a plus b squared is equal to a squared plus 2ab plus b squared. This is Euclid's Elements, Book 2, Proposition 4. We get the same outcome for quadruple 2. Quadruple 3 gives a squared minus b squared equals a squared minus b squared. When a equals 4 and b equals 1, we end up with the primitive Pythagorean triple 5 squared equals 4 squared plus 3 squared. The algebra shows that the theorem presented in Euclid's Elements, Book 2, Proposition 4, is always true irrespective of the format of the numerical input. The algebra proves that no power above the second can result in an analytically derived solution identical in form to the Pythagoras equation. It has therefore been conclusively proved that analytical solutions to the Fermat equation for powers above the second are impossible, hence an all-integer solution is equally absurd. Proof by contradiction. QED.